Have you ever wondered how video chat apps like Zoom and Omegle work? Well, I've built my own video chat platform from scratch, and today I'm going to show you how. Hey everyone, it's your main Rafael again, and today I'm back with another video. And on today's video I'm going to show you how the video chat platform I made in Trustly is functioning and how I built the project. If you're a developer or whether someone who's just curious about how video chat platforms work, this is the right video for you. I'm going to show everything briefly. If you're a developer or a software engineer, I will also cover everything needed: the tech stacks, the production stage, the server, everything. And also, if you're not a developer or someone curious, this video is going to be also suitable for you. Before going to the tech stacks and everything, let me share the story of this project. I've previously worked with some startups, but there was basic dashboard platforms, basic CRUD applications, those kinds of platforms. And the previous ones that I built was easy platforms, including the backend and including the front end. I mean, there's no much algorithm and there's no much code on the platform. It was easy to build. The story behind this project goes back to 6 months before. I was at a specific event, and it was a networking event hosted by Dashan Bank, and they were talking about networking, how your network is your net worth. Since then I got this idea, like enabling people to network instantly and in engaging way. I haven't any previous knowledge about building a video chat platform, but I studied that. I'm also going to share the technologies I used to build the video chat, and the industry standard, what kind of tech stacks are used on the video chat projects now. So I studied everything, including it's called WebRTC technology for the video chat. I studied that, and also I studied Redis. I haven't used Redis before at all, and I've studied that also. And also front end. Previously my expertise was in PHP. On the database, I only know SQL database, so I studied MongoDB, NoSQL database. It's a NoSQL database, and I studied that also. So I was forced to discover new things on this way. It was a great journey for me. That's enough for the story, and now I'm going to share you the tech stacks and the structure. Most of you asked how am I handling those users instantly. I mean, now we have 500 registered users, and how am I going to handle those users? And I'm also going to show you how I optimize the database and the server to handle more than 5k users. So make sure to watch the full video, and if you're new to the channel, make sure to subscribe and also like this video. If you are into startup journey and entrepreneur stuff, this is the right channel for you, so make sure to subscribe. So the architecture the platform has now is, as you know, if you're a developer, you know this already. We had a front end and we had a back end. So the front end is built using React.js. It's an excellent tool. I mean, there are also other options, Nest.js and other ones, but I prefer React because that's the one I've exercised with. So I used React.js for that. And for the backend, I use Node.js. If you're a developer, you know this already, so I use Node.js for the backend. So to explain the architecture for those of you who doesn't know what frontend and the backend, frontend is the one which is displayed to the user. When you go to Trustly.net, the one you see on the platform, the frontend, the sign up page, the components, the button, everything, that is called frontend. And the backend is the one that you don't see. It handles everything, including the requests. When you request to sign up, it processes on the database, it stores your data, everything, and the backend is responsible for everything besides the frontend. So that's the basic architecture generally in every platform you see. So how we are handling more than 5k users is that we had the front end first. The architecture is we had the front end, and we had a middleman between the front end and the back end, which is Socket.io. The technology is Socket.io. It handles web connections between the front end and the back end. So after that, we had a Nginx on the back end. It's a reverse proxy. if you don't know anything that I'm saying now, make sure to check those things. The reverse proxy is responsible to sit in front of the backend and access requests. It's like called an agent. Let's say it's an agent. So when you request from the front end to the backend, the reverse proxy receives that specific request and sends that request to the backend. So it's basically doing a security. It's useful for security reasons. It's useful to handle the load, but my reason was not security for using the reverse proxy. I used the reverse proxy Nginx. It's called Nginx. On the server side, on the backend, I've used multiple instances. To use those multiple instances, I used Docker. If you heard it before, it's a containerization technology. There are also other options, Kubernetes and others, but I used Docker because it's simpler to use. So I have built multiple containers. I have cloned the containers. I'm saying containers, the Node.js projects. Basically, what we have is most of the platforms nowadays are just one container. I mean, you just build a server and you're gonna host that specific server on the actual server. That server is the one which is receiving and sending back requests and responses. So in here, interestingly, that's not the case. We have 3 instances, server instances, and we had a reverse proxy. The reverse proxy is responsible to balance the load. Let's say 3 users request to the server at the same time. One request goes to the first server, the second request goes to the third server, and the third request goes to the third server. If there is a 4th user, another 4th user, the 4th user is going to be requested to the first server. So the load is balanced between the 3 servers. So besides that, how are those 3 servers communicating with each other? I mean, if you've heard what I said before, those 3 servers are responsible, those 3 instances are responsible for receiving connection requests, and they are responsible to find a match for you. So to clarify this thing for you, when you go to Interestly and picks a section, let's say you go to the business section, the server is going to store you in a waiting list. So you're going to be stored on the waiting list, and when someone goes to the platform with that specific section, the one you joined, you're going to be matched with the other user and you can talk with video chat. Let's say the first user request is sent to the first instance and the second user is sent to the second instance. So how are those instances communicate with each other, or how are they going to share data? So for that, I have used Redis. If you know Redis, it's a in-memory caching system. It's also used as a database nowadays, but it's an excellent tool. And there's a pub/sub functionality. It's called pub/sub, and I've used that for the instances to communicate with each other. If you are stored in the waiting list of the first instance, the second instance is also going to be informed about you, and if someone joins that second instance, they will match you with the first instance from the first instance. So that's the way how it works now. Okay, so let me show you here in actual code how it's structured in the file structure. It's easier for if you are a developer, it's easier to understand showing you the code. So here it is. So we had a balancer, which is the reverse proxy, which is balancing the load between the 3 instances, and we had the server and we had a front end. If you are familiar with using containers, using Docker, it's easier to understand. I mean, it's an excellent tool, and it's also great for working with other developers, and it's an excellent tool. I recommend you to use, if you don't use containers, I recommend you to use them. And here is the server, and we had a front end. So for those of you who doesn't know what front end is, it's just I've mentioned it before, it's just the part, the actual layout you are seeing when you go to the platform. When you go to Interestly.net, the interface you are seeing is the front end. So just let me clarify this for you. The compose file has 3 servers in it. We had cloned those 3 servers. I mean, this server is the node server, and we cloned those 3 servers. So we have 3 instances, and we had Nginx as a reverse proxy here, and it's listening on port 80, and we had here we had an Nginx configuration. So basically what the Nginx reverse proxy is doing is it receives a request, that's the backend, and it receives a request from the front end, then it balances the load between the 3 instances. I showed you before in the compose file, we had 3 instances here, and the Nginx reverse proxy is going to receive the server request, is going to receive the request, and it's going to separate the requests between those 3 instances. If one request is come, it goes to this one. If the second one comes, it goes to this one, and when the third comes, it goes to this one. So it's like a loop. There are multiple options to balance your load. This one is called round robin, and there are also multiple options to balance your load. I don't know, I forgot the names, but there's one like it goes to the least loaded one. I think there are also another ones, but I used round robin because it's easier and it's the default one. So here, so basically it's that, and here we have a Redis, which I mentioned before, which is doing the work for connecting those 3 instances together, communication between, which is responsible for the communication between those 3 instances. So basically that's what you're looking at. I don't know if you have noticed this, but in the compose file our instances are called Hulunate server. It's because the platform first name, the initial name was Hulunate. It's in Amharic, Hulu, then Nate. It's just basically it's because I haven't changed it because it requires much work. Everything said, let me show you the flow, how everything is working together. When you request to the platform asking for a connection, your request is going to be sent to one instance. There are 3 instances, but your request is going to be sent to one server. And if we have a Redis, we used Redis to store the waiting list. I mean, we don't use database for that because it's a temporary thing. So as I said before, Redis is a in-memory caching system. So we store someone named test joins the business section. Then that request is going to be sent to one server, and that server will fetch all the waiting list in that section. Let's say if he joins in business section, if that user joins in the business section, they are going to be the server is going to check if there is anyone waiting in the waiting list, not only in that one instance but in all instances. So if a user is found a waiting list if the user is found in the waiting list, they are going to be matched. So we get the socket connection done. So after the socket connection is done, the second part, the last part, which is playing the most crucial game in this platform, is WebRTC. So if you don't know WebRTC, it's a real-time communication technology. It's the abbreviation for web real-time communication, and it's an excellent technology. Nowadays, most of video chat platforms use WebRTC technology, including Zoom, Discord, every platform. For streaming, there are other options like HLS, HTTP live streaming, but for video chats and group chats, the best option is WebRTC. So let me show you how WebRTC establishes a video chat connection between 2 peers. Let's say user 1 and user 2 have a socket connection. I've explained previously how they get that socket connection, so they can communicate data with that person. And besides that, how the WebRTC connection works is that's the genius part of WebRTC. It doesn't require any server. Just we use the server for only signaling the data. When I say signaling, to establish that video connection, you need to have the other peer's data. Let's say it's called SDP, Session Description Protocol, but to establish that video connection, you need to have the other user's IP address, the other user's session description protocol, and those kinds of other also ICE candidates. So you need to get that data from the other user, and the other user is also going to need that specific data, the RTP, the ICE parameters, the ICE candidates, and the session description protocol from you. So we use the server to only exchange those data, but after this data is exchanged, the video chat is going to happen only between your laptop or your device and the other person's device. It's like a phone call. I mean, you just call to that user, and if he accepts that call, you're going to have a successful connection and data is going to start flowing. So the server is, in simpler analogy, the server is just doing the exchange of numbers. In mobile phone, let's say we use mobile phone, the server is only just doing the exchange of numbers. But when after you get the number of the other user, you can just call him, and if he accepts that, the connection is established. So there's no need for the server. But on the logics of the group chat and other functionalities and streaming, we're going to need a server. We don't need the server when only we use a simple peer-to-peer video chat application. But when we build a group chat functionality or other many-to-many streaming protocols or few-to-many streaming options, we are basically going to need an SFU, which is a selective forwarding unit. So we need that. We need a large amount of server. We need a server which has a large amount of computing power to handle all those groups and all those streams. But on the case of a video chat, which is one-to-one, we don't need the server. We only need the server to do signaling. But if you have seen the chat functionalities on the platform, on Interestly, we had a text chat section. So for that, we still use the server to exchange those texts. But for the video connection, even after you get connected, if the server crashes, you are still going to be connected because the connection is happening between you and the other device. So that's the magic of WebRTC. And on the production stage, to your surprise, now we are only using a 4 CPU VPS, which is bought here in Ethiopia locally. It's a Yagara hosted server. It's as I said before, it's a 4 CPU server, but it's handling well because we optimized the server to have multiple instances and to balance the load between them. So it's working perfectly. Maybe for those of you who has built a platform like this, or a platform which resembles this platform, my advice for you is in a production stage, a platform's production stage and a platform's development stage is quite different. So make sure to use a CI/CD, continuous integration and continuous development tools like Jenkins. For this project, I haven't used any CI/CD pipelines, so I was struggling when I started hosting the platform because on the development side there are so many things that are considered as a development, and when you host that specific code on the production stage, you have to change many things on your code, and you have to change many things on your code base or something. So make sure to use the ICD pipelines. That's my advice for you. So besides that, now we will have other iterations. The platform is going to have many iteration phases starting from the next month. We are adding group chats. I will also make another video building the group chat functionality. Any user can create a room and anyone can join that room and discuss as a group. So I'm also going to make another video showcasing how we change this peer-to-peer platform to a group chat, how we are coding it and how we are building it. So we will also have virtual events, we will also have profile customizations, and there are so many upcoming features. There are so many features in the future. Make sure to check the platform. It's interestly.net. I will put the platform's links on the description section. So thanks for watching the full video. I hope this video gives you basic analogy. It's not a devs video, but I'm sure it gives you a basic analogy about how video chats work. Thanks for watching. Make sure to subscribe to the channel, share this journey to others, and also make sure to like the video. Thank you for watching.